Fellow learners, this is Cameroon GCE O-Level Chemistry 0515, June 2024, Paper 2, question number 9. Before we proceed, I just want to give a kind reminder to those watching this channel now that if you have not subscribed to my channel, please take some time and subscribe so that other videos that will be coming up, you'll be receiving them. Thank you. Thank you very much for taking your time to subscribe to this channel. Let's get started. Section C, and we are on question number 9. The question reads, describe 9A, describe the extraction of aluminium from a named ore. You have to use a particular ore in this extraction. The B part state 2 uses of aluminium relating each use to its property. Okay, let's get started with A, describing the extraction of aluminium from a named ore. We are going to use a named ore in this description. In this description, you have to start with a named ore and give the detailed analysis of how aluminium is being extracted. You will have to give the advantages of using that ore. You will have to give the equations, the ionic equations occurring at the different electrodes. You will have to give tell how aluminum is being produced and tapped off from this process. Okay. Let's get started here. Well, we are starting with the ore. So let me give you an example of an ore. Example of a schematic diagram. This is a schematic diagram on how aluminum is extracted. Here, you will find, in this diagram, you will find this graphite electrode used by the graphite electrodes and the graphite cathode. You will see the steel cell surrounding the whole chamber. You will see the molten aluminum as it is being taken out, and you will see how they all dissolve in cryolite at a very high temperature. You will see what is happening at the electrodes, both the anode and at the cathode. Okay. This is what is expected of you. Listen, this is what is expected from you. Point number 1. Before I start, 9A, aluminum is extracted from what? From bauxite. The ore is bauxite. The ore is bauxite. Remember, bauxite is an impure aluminum oxide. It's an impure aluminum oxide. Okay, now, the first point is aluminum is extracted from bauxite, which is impure aluminum oxide. Bauxite is first purified and then electrolyzed because aluminum oxide is not reduced by carbon monoxide. That is the first point. The second point, the electrolysis process is expensive because of the high cost of electricity. The third point, aluminum oxide has a melting point of 2017 degrees Celsius. It has a melting point of 2017 degrees Celsius, which will require a large amount of heat energy to achieve to achieve this process and will further increase the cost of this production. And for this purpose, aluminum oxide is dissolved in another aluminum compound. We call it molten cryolite. And this is the formula of molten cryolite. Na3Al and F6. Point number 4. The advantage of dissolving this aluminum oxide in molten cryolite are: 1. The electrolyte can be maintained in the liquid state between 800 degrees Celsius to 1000 degrees Celsius, a temperature considerably lower than 2017 degrees Celsius, which greatly reduces energy costs. Again, one of the advantages of dissolving it in aluminum oxide is: 1. The electrolyte can be maintained in the liquid state between 800 degrees Celsius and 1000 degrees Celsius. This is a temperature considerably lower than 2017 degrees Celsius, which greatly reduces energy costs. Another advantage of dissolving aluminum oxide in molten cryolite is: cryolite improves the conductivity of the electrolyte. Cryolite improves the conductivity of the electrolyte. Point number the 6th point. The 5th point. Electrolysis is carried out in a steel tank using carbon electrodes that we call the graphite electrodes. These are the graphite electrodes here. The graphite electrodes, the graphite anode and the graphite cathode. That's why I say electrolysis is carried out in a steel tank using graphite electrodes. So these are the graphite electrodes. This is the tank here. That's the tank. This is the steel. This is the steel tank here. This is the tank containing the electrodes. Then, at the cathode, what is happening at the cathode here, and what is also happening at the anode, you will see it here. At the cathode, reaction at the cathode, you have to write that reaction. At the cathode, there is what we call, this is oxidation. This one is oxidation. So at the cathode, you have to, after giving the 5th point, saying that electrolysis is carried out in a steel tank using carbon electrodes or graphite electrodes, and that the anodes are carbon blocks that are lowered in the electrolyte, while the cathode is a carbon lining of the tank. Once more, look at it here. The anode are graphite blocks that are lowered into the electrolyte. This is the electrolyte here. This is the electrolyte. You see the electrolyte here in yellow. And then the anodes. The anodes are the carbon blocks that are lowered into this electrolyte here. These are the anodes. While the cathode is the carbon lining of the tank. This is the cathode here. This is the cathode. You see it there. That is the carbon lining of the tank. And the reaction that are taking place at the anode and the cathode, you have to write it, please, and make sure your equations are well balanced. At the cathode, which is the carbon lining, you have there. You will have there's a reduction that is taking place there. There is a reduction that is taking place there, where the aluminum ion will now, where the aluminum ion is now reduced into the aluminum that is being tapped off. Then at the anode, which is now deep into the electrolyte, those anode, what happened? The oxygen, there's production of oxygen there. There's oxidation that is taking place there. And oxygen is being released. And the oxygen that is being released, what happened? Let me get back to tell you what is happening there. See what is happening here? Oxygen is being released here. Then at the cathode here, at the cathode, that is where aluminum is being produced. That is the aluminum that is being produced. And it is produced near the carbon lining here. And when it is being produced, it is then tapped off here. So, once more, at the anode, at the cathode, aluminum is being produced there. There is a reduction that is taking place there. Because you could be asked in your exam, what is this reduction or oxidation that is taking place there? That's why I'm giving you these details. Then, at the anode, there is oxidation that is taking place there, and oxygen is being produced. Let's move on. Then again, point number 6. Molten aluminum that is collected at the bottom of the tank is siphoned off. As I told you, molten aluminum that is collected at the bottom, this molten aluminum that is collected at the bottom here, at the carbon lining here, the molten aluminum that is produced here is then tapped off. Okay, that's point number 6. That is point number 6. Then the oxygen, I'm still there. Then point number 7. Point number 6, molten aluminum that is produced, or molten aluminum that collects at the bottom of the tank is siphoned off or is tapped off. I've shown you. Now, point number 7, the oxygen produced at the anode, this is the oxygen. The oxygen produced at the anode react at the high temperature of the cell with the graphite anode. Remember, I told you this graphite at the anode here, this graphite that is dipped into the electrolyte. So the oxygen that is being produced here will now react with this graphite, with this carbon here. Graphite is carbon. So it reacts with carbon, and carbon dioxide is being produced. This is what happens there. So the oxygen produced at the anode will not do what? I said this is reaction of oxygen and graphite at the anode. So the oxygen produced at the anode will react with carbon, that's the graphite, to produce carbon dioxide. That is point number 7. Once more, the point number 7, the oxygen produced at the anode react at the high temperature of the cell with the graphite anode, producing what? Carbon dioxide, which escapes. Thus, the anode burns away and have to be replaced regularly. If they ask you in your exam, why is the anode regularly replaced? It's because it gets burnt with the oxygen that is being produced. The anode, which is the graphite, gets burnt with the oxygen produced at the anode, and it has to be replaced because it is always burning away when it reacts with oxygen. Okay, so point number 7 is that the oxygen produced at the anode react at high temperature of the cell with the graphite, producing carbon dioxide, which escapes. Thus, the anode burns away. The anode burns away and have to be replaced regularly. Once more, the high cost of electricity is the largest expense for this. Process. That's what you have to note. This is the largest expense of this process, which is carried out in regions where cheap electricity is there. This is just an additional fact, that because of this process here, it is very, very expensive, and this type of process is only carried out in cheap regions where electricity is cheap. That is, hydroelectricity is available. Now, after doing this, please know that this equation, the balance equation at the anode has cos. The equation at the anode at the cathode has cos. You can write reduction. The equation at the anode also has cos. You also write oxidation. It must be well balanced. Then a reaction of oxygen and the graphite. That is the oxygen, or reaction of the oxygen and the graphite at the anode, producing carbon dioxide that makes the anode to be regularly replaced. You also write that equation. That's why they say you should explain. Then do not forget to name the that it is extracted from bauxite. That is the ore, and which is an impure aluminum oxide. Okay, so these are the major points in this section. Thank you very much. Let's go to the second part of the question. The second part of the question is the second part of the question of this question is what? Has to do with the second part of the question has to do with importance of this extraction. Let's go to the question paper. The question paper says, question number 9. State 2 uses of aluminium, relating each use to its property. Okay, you have to go into the properties of aluminium and why they are being chosen. The properties of aluminium and why they are being chosen. So, 9b uses of this, relating it to their properties. Okay, let's go to some of the uses. Okay, now 2 uses of aluminium that are related to the property. The first use of aluminium is it is used to make food containers because of its resistance to corrosion. You know, aluminium it resists to react with oxygen. The way iron react easily with oxygen, aluminium does not react like that. That's why iron, when it reacts with oxygen, it produces rusting. It produces rust. But in this case, aluminium does not react with oxygen like that. So for that purpose, resistant to corrosion. Resistant to corrosion, that's the property. It hardly reacts with oxygen. So aluminium is used to make food containers. Food containers, you can see like canned drinks, tomato cans, and all those cans, aluminum cans, to seal food because of what? Aluminum, because of its resistance to corrosion. So aluminum, the first use is aluminum is used to make food containers because of its resistance to corrosion. Number 2. Number 2 has to do with what? Low density. It is light. Aluminum is light. That's the property. Low density because it is light. We now say the second use is aluminum is used to manufacture in the manufacture of aircraft. Aluminum is used in the manufacture of aircraft. All the flights we are moving in and other stuff like that. All these they use aluminum. Why? Because of its strength and low density. It is light. Even some boats, they use aluminum because it is light. It can easily flow on water. It's less dense. So density and resistance to corrosion are the 2 major properties I have taken in giving the uses. Once more, the first use on resistance to corrosion. 1. Aluminum is used to make food containers because of its resistance to corrosion. The second use, aluminum is used in the manufacture of aircraft because of its strength and low density. Thank you. If you write this in the second part of it, you will have all your scores. Thank you very much for that. We will continue with the last part of section C next time. We will continue with the last question of section C next time. Thank you for watching, fellow learners. Thank you for watching. Once more, for those of you who haven't subscribed to this channel, please do your best to subscribe so that all subsequent videos will come directly to you. Remember, my goal is not to ask for money for those watching this channel. My goal is for you to understand the basic concept in chemistry and become great engineers, become great medical doctors, become great pharmacists, become great aerospace engineers and agricultural engineers, educators, environmentalists, and whatever career you desire in life. Thank you. Wishing you best of luck in your exams.